In this video, I'll explain the position time graphs. So first, what is a position time graph? A position time graph is an XY plane where position is represented in Y values and time is represented in X values. You should also know that the slope in a position time graph is equal to the velocity. We know that the slope is equal to y2 minus y1 over x2 minus x1, and velocity is equal to the final position minus the initial position over the final time minus the initial time. Final position minus the initial position is the same as xf minus xi, and that's the displacement. So the change in values of y is equal to the displacement in the position time graph, because if we had a look at a slope in a position time graph, the slope is equal to y2 minus y1, and that's the change in the y values. So the change in the y values in a position time graph is equal to the displacement. You should also know that the change in x is equal to time, because the change in the x values in a position time graph is the same as the difference between the final time and the initial time. So let's take an example with some numerical values. Let's say that this point here is equal to 1 and 10, and that point is equal to 2 and 15. Now, what does 1 and 10 and 2 and 15 means in a position time graph? 1 and 10 means that at time equal to 1, the position is equal to 10 meters. At time equal to 1 second, the position is equal to 10 meters. And for the second point, 2 and 15, at time equal to 2 seconds, the position is equal to 15 meters. Let me clear off some space. If we get the slope of these 2 points, the slope will be 15 minus 10, the final y value minus the initial y value, over 2 minus 1, which is the final x value minus the initial x value, and that's equal to 5 over 1. So the velocity or the slope of these 2 points is equal to 5 meters per second. You should also know that a constant slope in a position time graph represents a constant velocity. What if we had a function that looks like that? It is a curve. In case we have a curve, that means the slope is changing. And if the slope is changing, that means we do not have a constant velocity. So in this case, we have an acceleration. Now let's get into some practice questions. In which time interval was a car traveling at a positive constant velocity? So let's imagine that this graph on the left simulates the movement of the car, where y are values of position and x are values of time. So here he wants the time interval that the car traveled in a positive constant velocity. We said earlier that velocity in the position time graph is equal to the slope. So in other words, he wants the time interval in which the car traveled in a positive slope. So a positive slope on the xy plane is looking up. So in which time interval does the slope or the line look up, it will turn out to be the line between the time interval of 2 and 3. It is the only point at which the line is looking up. So the answer will be time interval 2 to 3 seconds. Now the next example. What is the total time in which the car was moving at a negative constant velocity? Negative constant velocity means negative slope. So let's indicate the time intervals in which the car was moving in a negative direction or a negative slope. That means that the line is looking down. So we have a line drawn from point 0 and 2, so that's 2 seconds in total, and we have another line drawn from point 5 and 8. 8 minus 5 is equal to 3, so that's 3 seconds. So the total time in which the car was moving at a negative constant slope is equal to 2 plus 3, which is 5 seconds in total. Next example. In which time interval does the car stay at rest? Stay at rest means that the car is not moving, so it has no speed, means that the distance traveled is equal to 0. So the displacement as well will equal to 0. Thus the velocity, which depends on the value of the displacement, delta x over t, delta x will equal to 0, so the velocity will equal to 0 as well. And we know that the velocity on a position time graph is the same as the slope. So we are searching for the slope that's equal to 0. A slope that's equal to 0 is a horizontal line. So at what points in the graph a horizontal line is shown? Horizontal line is drawn from point 3 to point 5. So the time interval is 3 to 5 seconds. The last example. What is the average velocity of the car from point 5 to 8 on the x-axis? So here he wants us to calculate the velocity. In other words, he wants us to calculate the slope of the function at points x from point x equal 5 to x equal 8. So we already know that xi, or the first value of x, is equal to 5, and the other value of x is equal to 8. Now we need to find out the values of y. So let's analyze the graph. At x equal 5, value of y was equal to 1. So we'll write down 1 here. And at x equal to 8, the value of y was equal to negative 1. So we write negative 1. So we write negative 1. Now it is time to apply the slope formula, which is equal to x2 minus x1 over y2 minus y1. x2 is equal to 8 and x1 is equal to 5. y2 is equal to negative 1 and y1 is equal to 1. So the velocity or the slope will be equal to 3 over negative 2. So the velocity of the car in this time interval is equal to negative 3 over 2 meters per second.